Good day everyone. In this presentation, we will discuss software performance optimization strategies. So, what is software performance optimization? It is the process of improving the speed and efficiency of an application. It is an essential aspect of software development as users expect application to perform quickly and efficiently. In this presentation, we will discuss a few strategies for optimizing software application performance. But before we begin, let us first understand the importance of performance optimization. There are several reasons why software performance optimization is important. The first being user experience. If an application is slow, it can lead to frustration and a poor user experience. By optimizing software performance, software engineers can ensure that users have a smooth and enjoyable experience. Next, performance optimization ensures that software applications use system resources efficiently and can also reduce the amount of hardware required, leading to cost savings. Moving on, in today's fast paced market, performance can be a differentiator and can provide a competitive advantage. Customers are more likely to choose a software application that are fast and responsive. Lastly, performance optimization enables software applications to scale as number of users and data grows. This is especially important for web applications that need to handle a large number of concurrent users. The first step in optimizing software performance is to identify the bottlenecks that are slowing down the application. We will discuss three ways we can achieve this. First, we can use profiling tools. They measure the execution time of specific functions or methods within the application. This can help you pinpoint areas where the application is spending too much time. Second, we can perform load testing. It involves simulating a large number of users or requests to the application to see how it performs under heavy load. This can help you identify bottlenecks that occur under high load conditions. Lastly, we can look for common performance issues that can cause bottlenecks, including slow database queries that are not optimized, network latency, and inefficient algorithms. Since now we know how to identify performance bottlenecks, let us see a few techniques we can use to improve the performance. The very first technique is lazy loading. It improves the software performance by deferring the loading of non-critical resources until they are needed. Here are some ways we can achieve it. We can load only the essential content first, such as the page header, navigation menu, and the main content. Additional content such as images, videos, and other media can be loaded later as needed. Then, many popular front-end frameworks and libraries have built-in support for lazy loading. Additionally, there are many third-party plugins available that can simplify the process of implementing lazy loading in your application. Finally, one must prioritize content above the fold. Above the fold content refers to the position of a web page that is visible without scrolling. Prioritizing it can improve the perceived performance of your application and reduce the bounce rates. Next, reducing the number of HTTP requests is one of the most effective ways to optimize application performance as each HTTP request takes time to process. Software developers can take several steps to achieve this. To mention a few, we can combine multiple files into a single file and can reduce the number of HTTP requests needed to load a page. For example, multiple CSS files can be combined into a single file, reducing the number of requests needed to download them. Next, by using image sprites, developers can reduce the number of HTTP requests needed to load multiple images on a page. An image sprite is a single image file that contains multiple images. Lastly, minifying files such as CSS and JavaScript involves removing unnecessary white space and comments, which can reduce file size and improve download times. We can also use a content delivery network to improve software performance by distributing content across a global network of servers and delivering it to users from the server location closest to them. Here are some ways that using a CDN can improve software performance. A CDN can help in faster content delivery by reducing the distance that data needs to travel, resulting in improved application performance. Then, by distributing content across a global network of servers, a CDN can help to improve the scalability of an application by reducing the load on the application server and enabling it to handle increased traffic and user load. Next, a CDN can help to ensure that content remains available even if one or more servers fail. This is achieved by replicating content across multiple servers. Lastly, a CDN can help to reduce bandwidth cost and improve overall application performance by caching frequently accessed content. Another simple way to improve application performance is to minimize file size. As we all know, large files can slow down your application. Here are some techniques that can be used to minimize file size. We can minify our code by removing unnecessary white space and comments to reduce the file size. Then, file compression can significantly reduce the file size, making files faster to download and process. Popular compression formats include gzip. We can all agree that images can take up a lot of space, so using image compression techniques can significantly reduce file size. Next, vector graphics use mathematical formulas to define images rather than storing them as series of pixels. This can significantly reduce file size and improve image quality. Lastly, fonts too can take up a lot of space, so using font subsets which only include the characters used in a particular application can significantly reduce the file size. Now we have seen a few different ways to improve software performance. But how do you balance the need for software performance optimization with other priorities such as feature development and time to market? Feel free to pause the video and think about the answer. Well, balancing the need for software performance optimization with other priorities such as feature development and time to market can be challenging, but it's essential to create successful software products. Here are some strategies to help balance these priorities. First, we need to optimize software performance iteratively rather than trying to achieve maximum performance in one release. This approach allows the team to balance priorities and address performance issues in subsequent releases. Then, one must prioritize the features that have the highest impact on the user experience and business value. Features that require more significant performance optimization efforts can be prioritized lower or scheduled for a later release. Next, monitoring key performance metrics regularly, like page load time, response time, error rates, can quickly identify performance issues. Finally, agile methodologies promote continuous development and ensures that performance optimization is integrated into the development process. Now let's move on to other strategies that can help improve the software performance. Next up is optimizing database queries. It involves ensuring that queries are written efficiently and that the database is properly indexed. This can help reduce the time it takes to retrieve data and improve application speed. Here are some techniques that can be used to optimize database queries and improve software performance. First, properly indexing database tables can significantly improve query performance by reducing the time required to search for and retrieve data. Next, refining query structures and using more efficient SQL constructs can help to reduce query execution times. Then, by reusing existing database connections rather than creating new ones for each queries, developers can reduce the overhead associated with establishing new connections. Lastly, in some cases, denormalizing database tables can improve query performance by reducing the number of joins required to retrieve data. The next technique to significantly improve application speed and reduce server load is caching. So by storing frequently accessed data in cache memory, the application can retrieve data quickly without needing to access the database or file system. There are several types of caching techniques that can be used to improve software performance, including client-side caching, which involves caching data on the client side such as in a web browser cache or mobile app cache. This can reduce the need to fetch data from a remote server. Next is server-side caching, which involves caching data on the server side, such as in a memory cache or a disk cache. This can reduce the number of requests and queries that need to be processed by the server. Finally, we have the database caching, which involves caching frequently accessed data in a database cache, such as in a memory cache or a disk cache. This can reduce the number of database queries that need to be processed. The last technique we are going to discuss is code optimization. It involves identifying and eliminating bottlenecks in the code. Here are some techniques that can be used to optimize code. Using efficient data structures and algorithms can significantly improve performance by reducing the time required to process data. Choosing the right data structure and algorithm for a particular task can make a big difference in performance. Next, loops can be a significant source of overhead in the code. Minimizing them and using more efficient techniques such as recursion can improve the performance. Then, minimizing the number of I/O operations required can improve the code performance since I/O operations are typically slow. This can be done by using buffering, batching, or caching. Furthermore, code profiling tools can identify slow or inefficient code and can suggest optimizations to improve performance. Lastly, unnecessary computations can add overhead to the code execution. Eliminating them can significantly improve performance by reducing the amount of code that needs to be processed. In conclusion, it is important to monitor and optimize application performance continuously. By identifying and addressing performance bottlenecks, optimizing code, and using best practices, you can improve the speed, efficiency, and scalability of your software applications, resulting in a better user experience and increased productivity. Thank you so much for your attention.